These are the sorts of ages that we have to understand if we're going to understand evolution, and our brains are not equipped to do so. And when we were looking at our ancestors around there, we could be misled because it gives the idea that evolution is marching inexorably towards a climax, the climax being, of course, us. And that's not the way it was. Evolution was marching in thousands and millions of different directions at once. This here is not the Royal Institution Christmas tree, it's the Tree of Life, and it's a representation of a tiny, tiny fraction of the lines of evolution that there were. The origin of life is down here. This is the first 1,000 million years of life here, coming up here. Now, each of these branch points represents an ancestor of whatever lies up the branches from it. So, for example, there are the plants. This, I should say, is definitely not to scale. I've just noticed. So never mind that. Forget everything about scale on this tree. What is correct is the order of branching, but not the detailed distances of the branches. So this branch represents the plants. Those two are closer cousins of each other than they are of that one. This branch represents the primates with a gorilla and a human, and their common ancestor is there. This branch here represents carnivores, and there's a branch with a lion and a tiger, and their common ancestor there, which is more recent than the common ancestor of the bear and the dog. But that's the common ancestor of all the carnivores. Here we have the zebra and the rhino, not to scale, and you can see that they are more closely related to one another than either of them is to these cloven-hooved animals, the bison, the sheep, and the goat. The sheep and the goat have a very recent common ancestor. They're cousins. The bison has a slightly older common ancestor. Here we have two insects, a fly and a grasshopper, and they have an ancestor there. And then they share an ancestor with the spiders a little bit earlier on. This is a tiny fraction of the number of animals and plants that there should be on this tree. This tree should have some 10 or 20 million twigs around there. And the ancestors of all these animals are in the middle of the tree, going inwards like that. So all the ancestral portraits that we've just seen around there, they would be laid out along there. What we're looking at here are all modern animals. All those animals are cousins of one another, and they're cousins of us. These hamsters here are also cousins of us. Everything that's alive today is a cousin of us. These fish are our cousins. These elephants, these are, by the way, extinct elephants are our cousins. This swift is our cousin. We know that they're all our cousins because we know that they all have the same DNA code. The DNA code of all living things alive today is the same. And that is too improbable to have come about unless we have an ancestor. We're all descended from one remote ancestor which lived probably between 3,000 and 4,000 million years ago, and we are therefore all cousins. If we ever meet life from another planet, the creatures from there will not be our cousins. They will have evolved entirely independently. They won't have DNA, would be my guess. However, I would be prepared to say that they are likely to have quite a lot in common with us simply because there's a lot of similar problems to be solved in living, and those problems are likely to be the same all over the universe. So although they won't have DNA, they'll have something very similar in function. It'll do something very like DNA, and it'll work in a similar way to DNA. I'd also be prepared to put my shirt on the bet that they will have evolved by the equivalent of Darwinian natural selection. If we're ever visited by life forms from another planet, they will certainly have evolved the power to think and do science. Otherwise, they couldn't have got here. And their science is bound to be essentially the same as our science. This is because the principles of physics and chemistry are the same all over the universe. They'll have the same values of the constant pi as we have. They'll have Pythagoras' theorem. They'll have relativity, although they won't attribute it to Einstein. They'll probably find us pretty childish, but they'll be quite kind about our science. They'll pat us on the head and say, well, what you know about the universe is pretty much correct. You've got a lot to learn yet, but you're doing fine. Keep it up. That's what they'd say if they were talking to our scientists. What if they were talking to our best lawyers or literary critics or theologians? I doubt if they'd be so impressed. They might be, their anthropologists, the equivalent of their anthropologists, might be interested in us, but they would be bound to notice that our cultural beliefs are very local and parochial, not just by their standards, their universal standards, as they certainly would be, but even by our own standards. Because what people believe on our planet depends so much on whereabouts on the planet they happen to be born, which is a fairly odd thing. The Adam and Eve myth is believed by a lot of people in certain parts of the world, but if you go to other parts of the world, you'll find them believing very different myths. This is a Hindu myth, which is also very beautiful, and there are other Hindu myths as well. This is another Hindu myth of churning the milk of the ocean with a churn, gods and demons churning an axle with a turtle on the bottom, and out of the ocean came, as butter comes out of milk, came all living creatures. These creation myths are very beautiful, but they're all different from one another, and they can't all be true. And it's very odd if people believe simply what the other people in their own country happen to believe just because they're in that country. Look how scientists handle their disagreements now. Take a particular disagreement. Why did the dinosaurs go extinct? There are various theories. This is the theory that a comet or meteorite hit the Earth and caused a catastrophe that drove the dinosaurs extinct, and a lot of scientists believe that. A lot of scientists, on the other hand, believe that a virus killed the dinosaurs. And another lot of scientists believe that the mammals arose and ate the dinosaurs' eggs. Now, no doubt there's something going for all those theories. The point is that different scientists believe them. And the reason why they disagree is that there isn't enough evidence yet. Everybody knows, everybody agrees about what sort of evidence would be needed in order to make them change their mind. But suppose science worked like creation myths, or like languages. Here we have a map of world languages. In this red area, English is spoken. There, Spanish is spoken. There, Russian is spoken. And it's quite natural that you should be able to plot a map like that people should speak the language of their country. But what if scientific theories were like that? What if we had a similar map of the distribution of scientific theories? Suppose in the red area everyone believed the meteor theory of the dinosaur extinction. And in that area, everybody believed the virus theory. And in that area, everybody believed the mammals eating the eggs theory. Wouldn't that be a pretty silly sort of science? Imagine the scene, two scientists arguing, and one of them says, I believe that the dinosaurs went extinct because a comet hit the Earth. Why do I believe that? Because that's what my father and grandfather believed. And that's what people in my country have always believed. But I believe that it was a virus that drove the dinosaurs extinct. Why do I believe that? Because my father and grandfather believed it, and that's what people in my country have always believed. Or, suppose the conversation went like this. Never mind the evidence. I just know that a comet struck the Earth, because it's been privately revealed to me that a comet struck the Earth. But I just know that it was a virus, because I just know it, because I just know it, because I have faith that it was a virus. If you overheard conversations like that, you'd think they were pretty odd scientists, wouldn't you? You'd see no reason to believe any of them. Growing up in the universe,